Hi everyone, welcome to today's GCSE revision video. There's 5 days to go to your GCSE maths exam, and today rather than focus on the individual topic, I thought it'd be quite useful to do a recap of all the number topics. So I'm going to go through the number topics on the GCSE maths paper and go through a lot of the key information that you need to know for. For instance, what are your cube numbers? How do you write things as product or primes? Things like that. So in this video, we're going to do a recap on the number topics. Tomorrow, we're going to go through the statistics and probability topics. The day after, we're going to go through the algebra topics. And the day after that, we'll go through the geometry of the shape, space, and measure topics. So today we're going to focus on the number topics. There'll be lots of information, so remember, if you want to get a pen and paper and write some of this stuff down to remind yourself, feel free, or just sit back, relax, and enjoy the video. So let's get started. Hi, today we're going to be doing a recap of the GCSE Foundation number topics on the Corbettmaths Revision Checklist, so all those red topics. So in this video I'm going to do a recap. It's going to be a quick recap going through all of those topics. If you want a more detailed explanation, feel free to either underneath the logo there's the Corbettmaths video number for each topic, but also if you watch the GCSE Foundation revision video from 3 minutes and 39 seconds until 2 hours and 38 minutes and 1 second, there are all the number topics in that video. So in today's video we're going to be doing a recap of all the number topics on the Corbettmaths Revision Checklist. So these are the number topics in red. So we've got our multiplication, division, addition, subtraction, rounding, estimation, order of operations, order in decimals, topics such as prime numbers, best buys, percentage change, percentages, compound interest, and things like that. So in today's video, we're going to go through those topics, so let's get started. So our first topic is multiplication, division, addition, and subtraction. So it's very important you know those written methods of multiplication, division, addition, and subtraction, obviously for that non-calculator paper. And with 5 days to go, I'm pretty sure that you're going to be good at all of these anyway, that you'll be work out this addition, this subtraction, this multiplication, and this division using those written methods. If you need any extra help, there's videos here and there's some practice questions for you to try anyway. But these are your written methods, and it's very important that you know them, particularly for that non-calculator paper. Okay, our next topic is rounding. It's very important you can round numbers, for instance, to the nearest 100 or 1000 or 1 decimal place and so on. So for instance, if we wanted to round a number such as 235 to the nearest 100, you could consider it's in between 200 and 300, and it's closer to 200 than it is to 300, so we'd round that to 200 to the nearest 100. Alternatively, you could look at the digit in the tens column, which is a 3, and that means you round down to 200 rather than up to 300. So if the number in the tens column is a 0, a 1, a 2, a 3, or a 4, you'd round down. If it was a 5, 6, 7, 8, 9, you would round up. Alternatively, you could consider if it's closer to 200 or 300. And also, if we're rounding a number such as 5.18 to 1 decimal place, well, that's closer to 5.2 than it is to 5.1, so that would be 5.2. So it's important that you know how to round numbers. Okay, our next topic, estimation. Whenever you're dealing with an estimation question like this, it can be quite useful to round these numbers to one significant figure. So instead of doing 40.18 multiplied by 6.87 and so on, we'd round these numbers to be 40 multiplied by 7 divided by 0.5. And then we just do 40 times 7, which is 280, divided by 0.5. And then we see how many halves go into 280, which would be 560. So the answer there would be 560. And that's it. So whenever we're working at estimation questions, it can be very useful to round the numbers to one significant figure. Okay, next, our order of operations. It's very important you know the order of operations, so brackets, orders or indices, divisions and multiplications, additions and subtractions. So we need to work out any brackets first, then any squares or cubes or square roots and things like that, the orders or indices, then divisions and multiplications. Now they're of the same importance, so if you do have a calculation with just divisions and multiplications, you work from left to right. And finally, additions and subtractions. And again, if you've got a calculation with just additions and subtractions, you work from left to right. So here we've got work out 5 plus 10 multiplied by 2. So if I was to do this question, I'd have to do the multiplication first. 10 times 2 is 20. And we still have our 5 plus in front of that, and 5 plus 20 is equal to 25, and that's it. So we have to do this multiplication before we do the addition. Okay, next, order in decimals. So we may need to order decimals from smallest to largest, or from largest to smallest, and here's some decimal numbers, and we need to order them from smallest to largest. Really, what you could do is make all the numbers the same length, and if you look here, the longest one has got 3 decimal places, and this one's got 3 decimal places, so you can put an extra 0 there, an extra 2 zeros there, and an extra 0 there, and now you can compare them easily and see that this one's the smallest, and then this one's the next smallest, and then that one's the next smallest, that one's the next smallest, and then that one's the biggest, and that's it. Okay, let's have a look at our next topic. Okay, it's also important that you know how to work out your arithmetic with decimals. So for instance, adding them, subtracting decimals. So if you had something like this, 9.4 subtract 0.75, just make sure that whenever you're lining them up in the columns, that you line up the decimal points. They have all the numbers in the ones or the units column above each other. You have the decimal places lined up, and then you've got the tenths and the hundredths lined up. And you may need to put in placeholders such as that 0, and then you can just do the subtraction. And again, just put the decimal point beneath the other ones, and then work out the subtraction. If you want to multiply decimals such as this, you could do 9 multiplied multiply by 2 and get that answer. And because you made this number 10 times bigger and this number 10 times bigger, just get your answer and divide it by 10 and divide it by 10 again. So 9 times 2 is 18. If you divide that by 10, you get 1.8. And if you divide that by 10, you get 0.18. So you can just make them whole numbers and then just divide by 10 or 100 and 1,000 and so on. Or another way to do it is you could look at the question and see there's 2 digits after the decimal points. So the answer has to have 2 digits after the decimal point. So you could just do 9 times 2 is equal to 18. And then because you know it has to have 2 digits after the decimal place, you could do 0.18. And finally, if you were to work out something like this, 20 divided by 0.2, to do a division like this and divide by a decimal, it can be useful to multiply both of these numbers by 10 to get 230 divided by 2. And the answer to this will be the same as this, because not only is the number that you're dividing 10 times bigger, but the number you're dividing by is 10 times bigger as well, so you get the same answer. And whenever you do work this out, you get that's equal to 115. And that's it. Okay, next, multiples. So the multiples of 4 are 4, 8, 12, 16, 20, 24, and so on. So make sure you know the multiples of numbers. So for instance, the multiples of 9 would be 9, 18, 27, 36, 45, and so on. So that's multiples. Okay, next, factors. So factors are whole numbers that divide into a number without a remainder. So the factors of 20 would be 1, 2, 4, 5, 10, and 20. Because you can divide 20 by all of these numbers and there wouldn't be a remainder. You can do 20 divided by 4 is 5, 20 divided by 5 is 4, and so on. And to find factors, it can be quite useful to think of what multiplies together to give you 20. So 1 times 20 is 20, 2 times 10 is 20, and 4 times 5 is 20. So the factors of 20 would be 1, 2, 4, 5, 10, and 20. So that's how you can find factors of numbers. Okay, next, prime numbers. So prime numbers are numbers that are only divisible by 1 in itself. So for instance, 5 is a prime number because its factors are 1 and 5, but 9 is not a prime number because its factors are 1, 3, and 9. So it's got 3 factors. Prime numbers only have 2 factors, 1 in itself. So these are your prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so on. And it's very important to know those, so make sure you know those prime numbers. Okay, next, square numbers. So this means 6 squared, and it means 6 multiplied by itself. This little 2 means to square something. So you do 6 multiplied by 6 is equal to 36. If you got a bigger number, such as 58 squared, you would do 58 times 58, and then that would be your answer. So that's how you square numbers. You multiply by itself, and it's shown by that little 2. And in terms of your square numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So the square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, and so on, and just keep going on. So it's important to know the square numbers. Also, you need to know the square root symbol. So this is the square root symbol, and if you've got this, it means the square root of 49. So it's saying what number do you multiply by itself to get 49? And the answer would be 7. So this is the square root symbol, and you just think, what number do you square to get 49? So 7 squared is 49. Okay, cube numbers. So if we've got this little 3 now, that means cube. So if we had 10 cubed, that means 10 times 10 times 10. So to cube a number means you multiply by itself and by itself again. So 10 times 10 is 100, 10 times 10 is 1,000. So 10 cubed is 1,000. And your cube numbers, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. And it's important to know those cube numbers. Okay, next we've got cube roots. So this is the cube root symbol, and it means what number do we multiply by itself and by itself again to get 125? And the answer would be 5. So that's it, the answer is 5. Okay, next we need to be able to write numbers as product of primes. So if we were asked to write 40 as a product of primes, I would do it by writing 40, and then I'd think of 2 numbers which would multiply together to be 40. So 2 times 20 is equal to 40. 2's prime, so I'm going to circle it, whereas 20 is not, so we do another 2 branches. 2 times 10 is equal to 20, so we circle the 2. 10, 2 times 5 is equal to 10. So we've got all our numbers circled now. We've got 2 times 2 times 2 times 5. So 2 times 2 times 2 times 5 is 40. So 40 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5. And that's 40 as a product of primes. But we're asked to give our answer in index form. So the answer would be 2 times 2 times 2 is 2 cubed multiplied by 5. And that's it. So 40 is equal to 2 cubed times 5. Okay, next we need to know what LCM and HCF means. So LCM means the lowest common multiple, and HCF means the highest common factor. If you want to find the lowest common multiple of 2 numbers, such as 7 and 10, you could list their multiples. So you could list the multiples of 7 and list the multiples of 10. And the lowest common multiple is the first number in both of those lists. And in that case, that would be equal to 70. So 70 is the lowest common multiple of 7 and 10. If you wanted to find the highest common factor of 2 numbers, so for instance, if we've got the numbers 15 and 10, what you could do is you could list the factors. So the factors of 15 are 1 and 15. and 3 and 5. The factors of 10 would be 1 and 10 and 2 and 5. And then we just look for the highest common factor. So 1's a common factor and 5's a common factor and 5's the highest one. So the highest common factor of 15 and 10 would be 5. That's the largest number they're both divisible by without any remainders. Now sometimes you might need to find the lowest common multiple and highest common factor of some numbers that are a bit bigger. So for instance, if we want to find the lowest common multiple of 20 and 28, I wouldn't necessarily want to write down all the multiples of 28 because it'd be 28, 56 and so on. It'd be quite tricky. So what you can do is you can write both numbers as a product of primes. So write 20 as a product of primes, which is 2 times 2 times 5. You could write 28 as a product of primes, which is 2 times 2 times 7. And then you can do the still diagram. So you'd have here in the middle, you've got two 2's. They both got two 2's. So you can put two 2's in the middle. The 20's get an extra 5, so you put the 5 over there. And the 28's got an extra 7, so put the 7 over there. So we'll put all the numbers in the diagram. And now if we wanted to find the highest common factor, you would do 2 times 2, and that's equal to 4. So the highest common factor of these two numbers is 4. And if we wanted to find the lowest common multiple, we multiply all these numbers. So we do 5 times 2 times 2 times 7. And 5 times 2 is equal to 10, times 2 is equal to 20, times 7 is equal to 140. So the lowest common multiple of 20 and 28 would be 140. And that's it. So that's quite useful. So just remember, if you're doing this diagram to find the lowest common multiple and highest common factor, to find the highest common factor, you multiply the numbers in the middle, and to find the lowest common multiple, you multiply all the numbers in the diagram. Our next topic is indices. So in terms of indices, remember we've looked at squared. So if we've got 8 squared, that means 8 multiplied by 8. We looked at cubed. 10 cubed was 10 multiplied by 10 multiplied by 10. So if we've got 5 to the power 4, that means 5 multiplied by 5 multiplied by 5 multiplied by 5. And that'd be equal to 5 times 5 is 25. Times 5 is 125, times 5 is equal to 625. Also, it's important to know where the power button is in your calculator. Okay, next. Okay, so we've looked at positive indices, but what if the indices are negative? What if the powers are negative? So first of all, if you get any value apart from 0 to the power of 0, that's always equal to 1. So for instance, if we've got 20 to the power of 0, that's equal to 1. If we had 8 to the power of 0, that's equal to 1. Now, if you've got a negative power, such as 2 to the power of negative 3, you can do 1 over the positive power. So if we had 2 to the power of negative 3, we could do 1 over 2 cubed. 2 cubed, 2 times 2 times 2 is 8, so the answer would be 1 over 8. If we had 10 to the power of negative 2, you could do 1 over the positive power. So just get rid of that minus sign and make it positive, but put it on the denominator. And 10 squared is 100. So negative powers, negative indices, you just do 1 over and then do the positive power on the denominator. Okay, so our next topic is standard form. It's important you can write numbers in standard form. So that's where you've got a number that's bigger than or equal to 1, but less than 10, multiplied by 10 to a certain power. So here we've got 25,000. If we wanted to write that in standard form, we would have 2.5 because that's bigger than or equal to 1, but less than 10. And then we would multiply that by 10 to the power of, and then if we multiply by 10, we get 25. Multiply by 10 again, it'd be 250. If we multiply by 10 again, that'd be 2,500. And if we multiply by 10 again, that'd be 25,000. So we've multiplied by 4 10, so it'd be 2.5 times 10 to the power of 4. So it'd be 2.5 multiplied by 10 to the power of 4. 1, 2, 3, 4. Now, if we had 0.00009, that'd be 9 multiplied by 10 to the power of. And then when you've got these very small numbers, a bit of a shortcut is you can just count the number of zeros in front of that first digit. So you can just do 1, 2, 3, 4, 5. So it's going to be 9 times 10 to the power of negative 5. And now we've got some numbers here that are in standard form. Let's write them as ordinary numbers. So if we had 1.2 multiplied by 10 to the power of 8, well, we just move the digits 8 columns to the left. So that'd be 1, 2, and then we'd have 7 zeros. 1, 2, 3, 4, 5, 6, 7. And if we had 1.8 multiplied by 10 to the power of negative 3, we could just put our 3 zeros down, 0.0018. And let's just check that. If we move the digits 3 columns to the right, the 1 would move from here to 1, 2, 3. So there. So that's it. With numbers in standard form, we may be asked to add them or multiply them or divide them and so on. Now, multiplying and dividing them is quite nice because there's a bit of a shortcut with those. But in terms of adding them, if we were given something like this and we were asked to add these, you would write them out in full and then add them and then get your answer and write it back in standard form. So for this one, this would be 5, 3, and then 6 zeros. 1, 2, 3, 4, 5, 6. This would be 7, 9, 6. And then we'd move the digits 2 columns to the left. So we then add 6 zeros. 1, 2, 3, 4, 5, 6. Then you just add these using a column addition and then get your answer and write it in standard form. So that's how you would add numbers in standard form, and you'd use a similar approach if it was subtraction. In terms of multiplication, if we were to multiply numbers in standard form, such as this, what we can do is if we had 9 times 10 to the power 4 multiplied by 2 times 10 to the power 5, you can multiply the 9 and the 2 together to begin with. So 9 times 2 is 18. And then we've got 10 to the power 4 multiplied by 10 to the power 5. So remember the laws of indices, you add the powers there. So that'll be 10 to the power of 9. That'll be 18 multiplied by 10 to the power of 9. Now this isn't in standard form. Remember the number at the front has to be between 1 and 10. So what we're going to do is we're going to write 1.8. So we've made this 10 times smaller. So we have to make this 10 times bigger. So that would be 10 to the power of 10. So our answer would be 1.8 multiplied by 10 to the power of 10. In terms of division, well, we'll use a similar approach. If we've got 4.5 multiplied by 10 to the power of 7, and we're dividing that by 9 times 10 to the power of minus 5, we're going to divide these numbers, and then we're going to look at the powers here whenever we're doing this division. So in terms of 4.5 divided by 9, well, if we had 4.5 divided by 9, just using the bus shelter method, how many 9s go into 4? 0 remainder 4. How many 9s go into 45? 5. So 4.5 divided by 9 would be 0.5, so we'd have 0.5 multiplied by 10 to the power of, and now here we've got 10 to the power of 7 divided by 10 to the power of negative 5. I remember whenever we're dividing things with the same base, we take away the powers. So we've got 7 take away minus 5. So we've got 7 minus 5. And when we subtract the negative, well, we're adding, so we're going to do 7 plus 5, so that's going to be 12. So we'd have 0.5 times 10 to the power of 12, but this isn't in standard form because this number is not bigger than or equal to 1. So we're going to write 5 multiplied by 10 to the power of. And now, in terms of the power, well, we've made this 10 times bigger, so we have to make this 10 times smaller. So if you divided 10 to the power of 12 by 10, well, then you'd have 10 to the power of 11. So the answer would be 5 times 10 to the power of 11. And that's it. So in terms of standard form, it's important you can write numbers in standard form, that you can also write numbers that are in standard form as ordinary numbers, that you can add numbers in standard form, that you can multiply numbers in standard form, that you can divide numbers in standard form. Also make sure you can type it into your calculator, and also sometimes with standard form you might be given a context or a situation, so perhaps the circumference of planets and things like that. So make sure you're aware of how to tackle those standard form questions that involve situations, and the practice questions will be handy for that. Okay, so let's look at now fractions of amount. So to find a fraction of amount, if it's a nice fraction such as a half, you just divide it by 2. If it's a third, you just divide it by 3. So 24 divided by 3 is equal to 8. So a third of 24 is 8. If it's a nice fraction like a quarter, you just divide by 4, or half it and half it again. If it's a fifth, you just divide by 5, and so on. So if the fraction's got a 1 on the numerator, you just divide by what's on the denominator. If you've got a fraction where the numerator is not 1, so here we've got 4/5, you divide by the bottom and times by the top. So we're going to take our 35, we divide it by the bottom, so we do 35 divided by 5, that's equal to 7. And now we times by the top, so we take our 7 and we times by 4, and 7 times 4 is 28. So 4/5 of 35 would be 28. So in terms of fractions, divide by the bottom and times by the top, and that's it. Okay, next, adding fractions. If we want to add fractions, we just need to make sure they've got the same denominators. So if we've got a quarter plus 2/3, we just need to make sure they've got the same denominator. So here, if we've got quarters and thirds, we find a common multiple of 4 and 3, and I'm thinking 12 would be a good choice, so 12 and 12. To get from 4 to 12, you multiply by 3, so we multiply the numerator by 3, so that'll be 3/12, and then plus. And then to get from 3 to 12, we times by 4, so you multiply the numerator by 4 as well. 2 times 4 is 8. So we've got 3/12 plus 8/12, that's equal to 11/12. So whenever we're adding fractions, we need to make sure they've got the same denominator by finding equivalent fractions like this. If you've got mixed numbers, make them top-heavy fractions to begin with. So for instance, if this was 1 1/4, you'd make that 5/4, and then you would do the question like that. If it's subtraction, it's just the same, but instead of adding at this point, you would take away the numerators, and that's it. So in terms of adding fractions or subtracting fractions, just make sure they've got the same denominator, and then you can do it quite easily. Now, multiplying fractions. Multiplying fractions is quite nice. You just multiply the numerators and multiply the denominators. So if we were to work out 1/7 times 2/3, just multiply the numerators. 1 times 2 is 2. And then 7 times 3, multiplying the denominators, would be 21. So 1/7 times 2/3 would be 2/21, and that's it. So to multiply fractions, just multiply the numerators and multiply the denominators, and cancel down at the end if you can. And if the question was slightly different, such as 1 1/3 multiplied by 3/10, what we'd do is we'd make this mixed number a top-heavy fraction. So a whole is 3/3, and then another third would be 4/3. And a bit of a shortcut shortcut there is you just take this one, and you do 1 times 3 is 3, plus 1 is 4. So that's 4 thirds, multiplied by 3 tenths. So if you've got a mixed number, you just make it a top-heavy fraction to begin with, and then you just multiply the numerators and multiply the denominators. 4 times 3 is 12, and 3 times 10 is 30. So the answer there would be 12 30ths, but you can cancel that down. You can divide both of these numbers by 2. You can actually divide both of these numbers by 3 or by 6. I can actually divide them both by 6. So if I divide the numerator by 6, that'll be 2, and if I divide the denominator by 6, that'll be 5. So the answer would be 2/5. So you just multiply the numerators and multiply the denominators whenever you're multiplying fractions. Okay, next. So if we're trying to divide by a fraction, what we actually do is we multiply by the reciprocal. So here, if we had a half divided by 7/8, we take our half, and then instead of dividing by 7/8, we're going to multiply by 8/7. So we just find the reciprocal of this fraction, and in this case, I've just flipped it over. And then what we do is we just multiply. 1 times 8 is equal to 8, and 2 times 7 is equal to 14. And this can be cancelled down. We can half both of these to get 4/7. So whenever you're dividing by a fraction, what we do is we multiply by the reciprocal. And again, if you've got mixed numbers involved, just make them top-heavy fractions to begin with, and then do the question as normal by multiplying by the reciprocal. So that's how you add fractions, find the same denominators, multiply fractions, just multiply the numerators and multiply the denominators, and how to divide by fractions, multiply by the reciprocal. Now let's have a look at reciprocals. So here are some numbers, let's find the reciprocals. So if we wanted to find a reciprocal of 3/5, you just flip it over, so that would be 5 thirds. And you can change that into a mixed number if you wanted to. If you've got a number such as 8, you want to find the reciprocal of 8, well 8's the same as 8 over 1 or 8 wholes, so therefore it's reciprocal when we flip it over, that would be 1/8. Here we've got 1 and 1/6. Well, if we were to make that a top-heavy fraction to begin with, that would be 7/6. So that's equal to 7/6. And that means it's reciprocal when we flip it over, will be 6/7. And then if we had 0.75, if we wanted to find the reciprocal of 0.75, we write it as a fraction to begin with, which is 3/4, and then flip it over to find its reciprocal, which would be 4 thirds. And just remember that a number multiplied by its reciprocal will always be equal to 1. Okay, now we've got fractions, decimals, and percentages, and it's important to know these equivalent fractions, decimals, and percentages. So if you've got this on your Corbettmaths revision card, fantastic. Make sure you learn them, or on your windows, with your window pens, or if you've got a poster with these on it, fantastic. Just make sure you know these key equivalent fractions, decimals, and percentages, so know these off by heart. And then also remember how to convert ones that you're not familiar with. So know how to convert from a fraction to a decimal, a fraction to a decimal to a fraction, a percentage to a decimal, and a percentage to a fraction. So in terms of changing a fraction into a decimal, remember the line means divided by, so we just do 1 divided by 2, which is 0.5. So if you divide the numerator by the denominator, and the bus shelter method can be useful. So if if the numbers are a bit trickier and you don't know it off by heart, you can just make sure you do the bus shelter method and do the numerator divided by the denominator, and that'll change it into a decimal for you. And then once you've got it as a decimal, you can change it into a percentage by taking the decimal, multiplying it by 100, and then just putting the percentage sign on the end. So 0.5 times 100 is 50, so that means it'd be 50%. So that's how you convert a fraction into a decimal, a fraction into a percentage, and a decimal into a percentage. Now in terms of the other way, if we wanted to write a percentage as a decimal, we could just take the number, the 50, divide it by 100, which is 0.5, and then that'll be the decimal. And then to write a percentage as a fraction, I often write this number over 100, so I'd write 50 over 100 and then cancel it down, and that'll be a half. And that's how you would change a percentage into a decimal and a percentage into a fraction. And in terms of a decimal to a fraction, you could change it into a percentage first of all and then cancel it down. Or alternatively, here we've got 0.5, which is 5 tenths, so you could write 5 tenths and then cancel it down, and that's it. So that's how you convert your fractions, decimals, and percentages, and it's important you know how to do that and to know these key fractions, decimals, and percentages. You might also need to be able to express something as a fraction or as a percentage. So if, for instance, we had a box with 20 counters and 9 were blue, if we were asked to write down the fraction of the counters that were blue, that'll be 9/20. You just write 9 out of 20, 9/20. And if we were asked to write down what percentage of the counters are blue, like in this question here, we just need to change our fraction into a percentage. So 9/20, 9 divided by 20 is 0.45, so then that would be 45%, and that's it. So you can just take the fraction, divide the numerator by the denominator, and then just write it as a percentage, and that's it. So that's how you express as a fraction and also express as a percentage, just convert the fraction into a percentage. Okay, next we've got percentages of amounts, and that's a very important topic, so it's important you know how to work out percentages of amounts without a calculator. So if you want to find percentages of amounts without a calculator, I would use these 4 building blocks. To find 50% of a number, you divide by 2. To find 25% of a number, you divide by 4, or you half it and half it again. If you want to find 10% of a number, you divide by 10. And if you want to find 1% of a number, you divide by 100. And once you find these 4 building blocks, you can work out any percentage. So for instance, if I wanted to work out 11%, I could get 10% and 1% and then add them together. If I wanted to work out 30%, I could get 10% and then add 3 of them together or times it by 3. If I wanted to find 90%, I could get 10% and take it away from 100%, or I could get 10% and times it by 9, or I could get 50% and 4 10% and add them up and so on. So these building blocks will be really helpful for you whenever you're dealing with percentages of amounts without a calculator. And then in terms of percentages with a calculator, one approach is to just divide by 100 and then multiply by the percent you want. So find 1% and then multiply by the percentage you want. So here, if I wanted to find 19% of 240, I would take 240, I would divide it by 100 to find 1%, which is 2.4, and then I would take the 2.4 and I would multiply that by 19 to find 19%. So 2.4 multiplied by 19 is equal to 45.6. So that means that 19% of 240 is 45.6, just dividing by 100 and times it by 19. If I wanted to find 73% of a number, I'd divide by 100 and times by 73, and so on. Another approach is to use a multiplier. So what we could do is if we wanted to find 19% of a number, we could take the 240 and multiply that by 19% is the same as 0.19. So 0.19 is a decimal. So you could just multiply by the decimal, just change the percent to a decimal, and then that's a multiplier. And if you work this out, you get 45.6, and that's it. So in terms of finding the percentage of amounts, you could use a multiplier, or the approach I like to use is just divide by 100 and multiply by the percentage you want. Okay, let's have a look at our next topic, percentage change. So if you encounter the terms percentage change, percentage increase, percentage decrease, percentage profit, percentage loss, and so on, then you might want to use the formula percentage change equals change divided by original times 100. So if we had the height of a plant that increases from 30 centimeters to 46 centimeters, and you've been asked to work out the percentage increase, well, you find the change, well, it's gone up by 16. So the change is 16 divided by the original, which is 30, and then multiply by 100, and you just work that out, and that'll be your percentage change. So just remember, change divided by original times 100. Okay, sometimes you might encounter simple interest. So simple interest is where the interest stays the same every single year. Now in terms of these questions, not as common as the compound interest ones, and I'll talk about those in a second, but you may encounter them. So if you see the term simple interest, this is how you'd work it out. So if we had the question said £300 is invested for 2 years at 10% per year simple interest, what that means is that 10% of £300 is added every single year. So if we work at 10% of £300, is equal to £30. So that means that every single year £30 interest is earned. So over 2 years you would just take your £30 and multiply that by 2, and that's equal to £60. So how much interest is earned? £60. If it was 3 years it'd be £90. If it was 4 years it'd be £120, and so on. If the question said to work out the total amount of money in the bank account, I'd add that £60 onto the 300 and the answer would be £360. But the question just said to work out the total interest, so the answer is £60. So simple interest, the amount of interest stays the same every single year. Now they're not as common as compound interest. So let's have a look at compound interest. So here's a compound interest question. James invests £8,000 in the bank for 3 years and earns compound interest of 5% per year. I've been asked to work how much money he has in the bank at the end of 3 years. So in terms of this question, you could do it manually. You could take the £8,000, increase that by 5%. That's how much you'd have at the end of 1 year. Get that in the amount now, increase that by 5%. That's how much you'd have at the end of the 2nd year. And then take that amount and increase that by 5%. That's how much you'd have at the end of the 3rd year. Or you could use this formula. It's a really useful formula whenever you're dealing with compound interest, but also growth and decay questions. And that's initial multiplied by the multiplier to the power of time. So here the initial amount of money is £8,000. The multiplier, well, it's going up by 5% every single year. So if we increase something by 5%, we'd have 105% or 1.05. So if you want to increase something by 5%, you multiply it by 1.05. That's our multiplier. And then to the power of time, which would be 3. And then you just work that out. So this is a really useful formula. Initial multiplied by the multiplier to the power of time. And that's really useful for your compound interest questions. Okay, next, reverse percentages. So sometimes, rather than increasing something by a percentage or decreasing something by a percentage, you might have a situation where something has been already increased or decreased by a percentage, and you have to find the original. So let's have a look at a question. We've got Rebecca's been given a 35% pay rise. She's now paid £13.77 per hour. And the question said, what was Rebecca's pay before the pay rise? So in terms of this question, we're trying to find how much her pay was before the pay rise, so before it went up by 35%. So that's how we know it's a reverse percentages question. So in terms of this question, we could approach it in a couple of ways. So one approach is, she's been given a 35% pay rise. So she would have had 100% to begin with. If you increase that by 35%, you would have 135%. And that's equal to, in this case, £13.77p. Now we want to find what her pay was before the pay rise. That's 100%. So I would divide both of these by 135. So I would divide by 135. and I would divide by 135. That would tell me what 1% is. So I'd have 1% is equal to something, and I would just divide and find out what that is. And then I want to find out what 100% is, so I would then just multiply by 100 and multiply by 100. And if I did that, we find out what 100% is, and that's how much money she was paid per hour before her pay rise. So you just take this amount of money, you divide by 135 to get 1%, and then times by 100 to get what it was to begin with, 100%. Another way to do this question is, if you increase something by 35%, the multiplier would be 1.35. That's how you increase something by 35%. You multiply by 1.35. So to reverse the percentage question, you could divide by the multiplier. So we could take the £13.77p and divide it by 1.35, and then that would be the answer as well. So you could use either approach. Okay, next. Ratio is a very important topic, a very important number topic. So there's lots of different ratio skills you need to be able to do. One of them, simplifying ratios. So if you were given something like this ratio, you could just cancel it down. So both of these numbers are divisible by 4. So you divide both of these numbers by 4, you would get 7 to 10. So that would be this ratio simplified. So you just cancel it down, a bit like cancelling down fractions. Okay, now sometimes with ratio we're asked to express things in the form n to 1 or 1 to n. So if you've been given a ratio such as 16 to 5 and we want to express it in the form n to 1, as you can see here, on the right hand side we've got 1 and here we've got 5. So we want to make this 5 1. So what we're going to do is we're going to divide both numbers in this ratio by 5. So we're going to divide the left hand number by 5 and the right hand number by 5. 16 divided by 5 is equal to 3.2, and then 5 divided by 5 is equal to 1. So we've got it in the form n to 1. We've got 3.2 to 1. And that's in the form n to 1, a number to 1. So we made the number on the right hand side 1. If we were asked to express this ratio 16 to 5 in the form 1 to n, we would divide both numbers by 16, because that would give us the 1 on the left hand side, and then we'd have something on the right hand side, that n, that number. And that's it. Sometimes we're asked to express ratios as a fraction or ratios as a percentage and so on. So here we've got a box containing white and grey beads, and they're in the ratio 2 to 3. So if we want to find the fraction of the beads that are grey, so if we consider the ratio, for every 2 whites is 3 greys. So that means white, white, grey, grey, grey. And if we want to find what fraction of the beads are grey, we've got 3 out of 5. So it's just going to be 3 out of 5, and that's it. So if you add together the numbers in the ratio, that's what will go in the denominator, and the number for the one that you want, so in this case the 3 for the grey, goes in the numerator, and that's it. Also with ratio, sometimes you ask to share a number in a given ratio. So here Jack and Chloe are sharing £75 in the ratio 2 to 3. And if you want to share something out in a ratio such as £75 in the ratio 2 to 3, you add the numbers in the ratio. So we do 2 plus 3 is equal to 5. Then we look at what we're sharing out, the £75, and you divide it by that. So we're going to do 75 divided by 5, and that'll tell you how much is in one part. And 75 divided by 5 is equal to 15. So that means it's £15 in one part. So in one part. Now if we have a look, Jack gets 2 parts, so we take the £15 and we multiply by 2, and that tells how much Jack gets, which would be equal to £30. That's for Jack. And in terms of Chloe, she gets 3 parts. We take the £15 and we multiply by 3. And 15 multiplied by 3 is equal to £45. So that means that Chloe gets £45. So the share quantity in a given ratio, you just add together the parts in the ratio. You then take what you're sharing and divide it by that answer. And then you multiply that amount, that answer, by each of the numbers in the ratio. And that'll tell you how much each person gets. And that's it. Okay, next. Sometimes with ratio questions, rather than sharing out the total, they give you one of the values. So here we've got the ratio of lemon sweets to strawberry sweets is 5 to 3. So for every 5 lemon sweets, there's 3 strawberry sweets. And we're told there's 120 lemon sweets, so we're told one of the quantities, and we want to find out how many strawberry sweets there are. Now you could do this by considering for every 5 lemon there's 3 strawberry, and just then go for 10 lemon there'd be 6 strawberry, for 15 lemons there'd be 9 strawberry sweets, and so on. Or a quick way to do that would be to look at the lemon sweets. There's 120 lemon sweets and divide that by its number in the ratio. So 120 divided by 5, because the 5 parts is lemon. 120 divided by 5 is equal to 24. So there's 24 sweets in one part, and then multiply by the strawberry sweets number in the ratio, which is 3. So 24 multiplied by 3 is equal to 72. So that means there's 72 strawberry sweets in the tub, and that's it. Okay, next let's look at currency. So sometimes you may be given an exchange rate such as £1 equals €1.40. So in other words, every pound is worth €1.40. And you may be asked to exchange something such as £800 into euros. So what you would do is you just multiply this number by 1.4, because for every pound you get €1.40. So if we do £800 multiplied by 1.4 or 1.40, that'll tell us how many euros you'd get. So £800 multiplied by 1.40 is equal to 1,120. So if we've got a certain number of pounds and we want to exchange that into a certain currency, we just look at the exchange rate and then just multiply it by, if we've got £1 equals so much of a certain currency, just multiply the number of pounds by that number in the ratio. So we've done 800 multiplied by 1.4, and that changes it into how much of the foreign currency you'd get. And to go back, we would divide. So if we've got 105 euros and we want to go back into pounds, we just take 105 and divide it by 1.40 or 1.4, and that's equal to 75. So that's 75 pounds. So the change into the foreign currency, you multiply here, and then to change back, we divide, and that's it. Next, recipes. You may be given a list of ingredients and told it serves 5 people, such as this, and you might need to find out how much of each ingredient you need for 10 people. Well, you just double all these. 15 people, you just multiply all of these by 3. 20 people, you just multiply each of these by 4, and so on. If you needed to find out how much you'd need for 1 person, you would divide all of those by 5. If it was 2 people, perhaps, you could divide them all by 5 to find out for 1 person, and then multiply by 2, and so on. So recipes, make sure you know, if you've got a list of ingredients, how you would find out how much of each ingredient you need to serve different numbers of people. Next, make sure you're confident with your negative numbers. So make sure, for instance, if you've got 6 take away 10, you know that would be equal to negative 4, because 6 minus 10, you take away 6 to get to 0, and then another 4 would be minus 4. Make sure you can do questions like this, minus 7 plus 12. So if you add 7, you get to 0, then you get another 5, so the answer would be 5. Make sure you can add negative numbers. So if you add negative numbers, you would go down. So 5 plus minus 3 means we're going to go down 3, so the answer would be 2. If we've got minus 10 plus minus 5, well, adding a negative means you're going to go down. So minus 10 plus minus 5 means you're going to go down another 5 from minus 10, so that'll be minus 15. And make sure you know, if you've got something like this, 8 subtract minus 7, well, subtracting a negative means you go back up. So 8 minus minus 7 means you're going to go back up 7, so that'll be 15. So make sure you're confident with your negative numbers, particularly for that non-calculator paper. Next, make sure you're confident with multiplying and dividing negatives. So positive times positive is a positive, obviously. A positive times a negative is a negative, and a negative times a positive is a negative, and negative times a negative is a positive. In other words, if they're both the same, so positive times positive or negative times negative, you get a positive answer. And if they're different, so one of each, you get a negative answer. And it's the same rules for division. Also, make sure you're confident with your place value. You may be given a number, for instance, 7,817, and you might be asked to write down the value of the digit 8 in that number. And obviously, because it's in the hundreds column, the answer would be 800, and so on. So make sure you're confident with your place value. Also, make sure you're confident with error intervals. So here we've got a question. It says Frank rounds a number y to the nearest 10. So he rounds a number to the nearest 10, and his answer is 130. And we've been asked to write down the error interval for y. So his number could have been bigger than or equal to 125, because 125 is the lowest number, that whenever you round it to the nearest 10, you'll get 130. And Frank's number could be anything up to, but not including, 135. So his number y would be bigger than or equal to 125, but less than 135. Frank could have chosen any number in that interval. So make sure you're happy with error intervals. Next, money questions. It's a good chance you're going to encounter some money questions on the GCSE Maths exam. I would imagine there'll be some on the non-calculator paper and some on the calculator paper as well. If you go to videos 400, there's 400A, B, C, and so on Corbettmaths, you'll see a load of different topics involving money. For instance, regular payments, VAT, discounts, things like that. Reading meters. So make sure you're confident with your money topics. Just one thing I want to mention with money: whenever you have an answer, and for instance, if it was £1.50 and your calculator says 1.5, don't just write 1.5. Make sure you put the 0 on the end. So make sure whenever you're dealing with money in pounds, make sure it's got 2 decimal places. And another thing to watch out for is never include a pound sign and a pen sign for the same number. Okay, another topic you may encounter is best buys. So in terms of best buys, 2 approaches that I use whenever I'm dealing with best buys is either to take the cost and divide it by the amount. So in terms of these biscuits, we could take the costs and divided by the number of biscuits in each packet. So you could do 78 divided by 6, and that's equal to 13p. So that means it's 13p per biscuit in that packet. Or here you could take the £1 or the 100 pennies and divide it by 8, and that's equal to 12.5p per biscuit. So as you can see, this packet of biscuit is better value for money. So that's one approach you could use. And in terms of if you've got, for instance, bottles of perfume and you've got so many milliliters, again, you could take the cost and divide it by 50 to find out the cost per milliliter. And you could take the cost and divide it by 75 and find the cost per milliliter and see which one's better value for money. So that's one approach. Or another approach is to find the cost for the same amount. So in other words, for these biscuits, find that the cost for 24
24 biscuits, finding a common multiple here. So I find the lowest common multiple is 24, and then find the cost for 24 biscuits. So you could buy 4 of these packets and 3 of these packets and see which one's better value for money. And likewise for the perfume, you could find the cost for 150 milliliters. So if you bought 3 of these bottles of perfume, and if you buy 2 of these bottles of perfume, you can then find out the cost for 150 milliliters and find which one's better value for money. Now in terms of proportion, there's a couple of different types of proportion questions you may encounter. One, you may encounter a formula that they give to you. So you've got here that the number of months M to complete a piece of research is found by 2,400 divided by N, where N is the number of scientists. And the question says, how long should the research take if 30 scientists are working on it? So here you're just substituting 30 for N and you do 2,400 divided by 30, and that's the answer. So you may encounter proportion questions where you're given a formula, or you may encounter proportion questions like this, perhaps proportion questions where you're dealing with time and things like that, where it says it takes 20 hours for 3 pumps to fill a swimming pool. And the question says, how long would it take if 4 pumps were used? Well, obviously, if you're using more pumps, as long as the pumps are all going at the same rate, it'll take less time for 4 pumps rather than 3 pumps. And the way I would do a question like this is, well, if it takes 20 hours for 3 pumps, well, it would take then 60 hours for 1 pump because it would take 3 times longer. And then if 4 pumps are used, it would take a quarter of the time. So you just do 60 divided by 4, and that'll tell you how long it would take for 1 pump. So you may encounter questions like that. And if you encounter the proportional graphs, this is y is inversely proportional to x, so it would look like that. As x increases, y decreases. Y is proportional to x would look like that. As x increases, y increases. And y is proportional to x squared would look like that. It would be the right-hand side of that quadratic graph. So the proportional graphs would look like that. And finally, another thing that's very important is that you know how to use your calculator to do questions. So obviously your calculator display may be slightly different depending on what type of calculator you're using. One thing I would say is make sure you've got a little D on the top of your calculator display to make sure your calculator is in degrees mode, because if you're doing trigonometry, it's very important that you've got it in degrees. So make sure your calculator's got a little D on the top, and if you're not sure on how to change that, speak to your maths teacher and they can show you how to change that into a little D at the top of your calculator. Also make sure in terms of your calculator you know where buttons are, such as the square root button, so here, here, and here. Make sure you know where the power button is, here, here, and here. Make sure you know where the squared button is, here, here, and here. Make sure you know where your brackets are, here, here, and here. Make sure you know where pi is on your calculator, so press shift and then that button, press shift and then that button, or in this calculator, shift and then that button, and so on. So make sure where all the key buttons are in your calculator, make sure you're confident with that. And that's it. So in this video, we've gone through a lot of topics. We've looked at our multiplication, division, addition, subtraction, so make sure you're confident with your operations and know how to do the written methods for those. Rounding, make sure you know how to round to the nearest number, the nearest 10, 100, 1,000, 1 decimal place, 2 decimal places, 1 significant figure, 2 significant figures, things like that. Estimation, so whenever you're dealing with estimation questions, it can be useful to round to 1 significant figure, so 1 digit followed by zeros and so on. In terms of order of operations, make sure you know the order of operations, so your brackets, then your orders or your indices, that's like your squareds and your square roots and your cubes and things like that. Then your divisions and multiplications, and then your additions and subtractions, so make sure you know the order of operations. Make sure you know how to order decimals, so in terms of ordering decimals, some students find it quite useful to put zeros on the end to make them all the same length as each other, and then just put them in order. Make sure you're confident with your arithmetic with decimals. Make sure you're confident with your multiples, so the multiples of 7, 14, 21, 28, and so on. Factors, so the factors of 30 would be 1 and 30, 2 and 15, 3 and 10, 5 and 6, and so on. Your prime numbers, so prime numbers are only divisible by 1 and itself, so 2, 3, 5, 7, 11, and the only even prime number is 2, and 1's not a prime number because it has to have 2 factors, 1 and itself, so 2, 3, 5, 7, 11, and so on. Square numbers, so square numbers and square roots, so your square numbers, so how to square a number, remember the little 2 above it, and that means to multiply by itself, and the square numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9, so 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. Your square roots, that little square root symbol, the little square root symbol like that, that's the square root symbol, so if you've got the square root of 36, that would be 6, because 6 times 6 is 36. Make sure you know how to cube numbers, so remember the little 3 above it, so for instance 2 with a little 3 above it would be 2 cubed, and that means 2 times 2 times 2, which is 8. And know your cube numbers, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. It's also useful to know that 10 cubes is 1,000 as well. Make sure you know the cube root symbol, so the little cube root symbols, that is like the square root symbol with a little 3 above it, and the cube root of 8 would be 2, because 2 times 2 times 2 is equal to 8. Know how to write things as product of primes, so do your little prime factor tree, circle the prime numbers. If they say to write an index form, make sure you do the powers above the numbers. The lowest common multiple and the highest common factor, if you ask to find the lowest lowest common multiple of two numbers, such as 4 and 5, you could write down their times tables and find that it's 20. Or you could use the product of primes, and if you do the circles, you'd multiply all the numbers in the circle to find the lowest common multiple. In terms of the highest common factor, if you've got two numbers such as 25 and 30, you could write all the factors out and find the highest common factor, which would be 5, the largest number you could divide them both by. Or if you do the product of primes, then you multiply the numbers in the middle of the circles where they overlap. Indices, make sure you know how to work out your squares and your cubes into power 4 to the power 5 and so on, and make sure you know the laws of indices, and we'll come back to that in the algebra video. Make sure you know your negative indices. So if you got something, for instance, 5 to the power of negative 2, that's the same as 1 over 5 squared. 5 squared is 25, so that's 1 over 25. So if you've got a negative power, put 1 over the positive power. Anything to the power of 0 apart from 0 is equal to 1, so make sure that if you've got, for instance, 10 to the power of 0, that's equal to 1. Know how to write numbers in standard form, so it's a number that's bigger than or equal to 1 but less than 10, multiplied by 10 to a certain power, and make sure you know how to write numbers in standard form, how to multiply numbers in standard form, add numbers in standard form, divide numbers in standard form, and be confident with tackling problems which may include numbers in standard form. Fractions of amount, divide by the bottom and times by the top. Adding fractions, so make sure whenever you're adding fractions, the fractions have got the same denominator, and if they're not, make sure you then get equivalent fractions with the same denominator. And if you've got mixed numbers, make sure you make them top heavy first and then deal the question like you would do normal fractions or fractions that aren't top heavy. Multiplying fractions, you just multiply the numerators and multiply the denominators, and again if you've got mixed numbers, make them top heavy and then just multiply the numerators and multiply the denominators, and if you've got a top heavy fraction at the end, turn it back into a mixed number. Dividing fractions, well, just multiply by the reciprocal of the fraction you're dividing by. Reciprocals, well, if it's a fraction, you just flip it over. If it's a whole number, then it would just be 1 over that number, and so on. Fractions, decimals, and percentages, know your equivalent fractions, decimals, and percentages, and know how to change a fraction into a decimal. Just divide the numerator by the denominator. How to change a fraction into a percentage. If you can get an equivalent fraction with 100 on the bottom, that'd be fine, or change it into a decimal and then change it into a percentage. To change a decimal into a percentage, just multiply by 100 and then put the percentage sign on the end. To change a decimal into a fraction, if it's got one decimal place, then it'd just be that number over 10. If it's got two decimal places, it would just be that number over 100 and then just cancel down. To change a percentage to a decimal, just take off the percentage sign and divide by 100. And to change a percentage into a fraction, just put it over 100 and then just cancel it down. To express as a fraction, you just put what you're looking at over the total. And then to express as a percentage, express as a fraction, then convert your fraction into a percentage. Next, percentages of amounts. Make sure you're confident with your non-calculator percentages of amounts. So to find 50%, divide by 2. To find 25%, divide by 4, or half it and half it again. To get 10%, divide by 10. To get 1%, divide by 100, and use those building blocks whenever you're doing percentages of amounts without a calculator. And then with a calculator, just divide by 100 and multiply by the percentage you want. Percentage change, that's change divided by original times 100. Simple interest, well, that's where the interest stays the same every single year. So you just work out whatever percentage it is and then just add that amount on every single year. The percentage doesn't change. Compound interest, for calculator questions, I would definitely use initial multiplied by the multiplier to the power of time. For non-calculator questions, then you would do it manually. So for instance, if some money was invested at 10% compound interest for 2 years, you'd increase it by 10% to find how much is there at the end of the first year, and then increase that by 10% to see how much there'll be then in the bank account at the end of 2 years. Reverse percentages, well, there are questions where you need to find out what the original was. So I would often try and figure out what percentage you've now got, find 1% and then find 100%. Or consider what multiplier would have been used and then divide by the multiplier. Ratio, know how to simplify ratios. So a bit like simplifying fractions, so simplifying ratios. Know how to express in the form 1 to n and n to 1. Know how to share a total out in a given ratio, so add together the numbers in the ratio and then divide the total by that number of parts and then find out how much is in one part and then multiply by each of the numbers in the ratio. Know how to deal with ratio questions perhaps whenever you're given one of the quantities, so divide by that and multiply by the other one and so on. In terms of currency, to change into the foreign currency, if it's in the form of £1 or so many of the foreign currency, multiply by the number in the exchange rate, and to change back into pounds, divide by the number in the exchange rate. Recipes, so if you're given a list of ingredients, know how to find how much you'd need for one person, two people and so on for that list of ingredients. Negative numbers, so know how to add and subtract negative numbers, but also that whenever you're multiplying, two of the same, whenever you multiply two positives or two negatives, you get a positive answer, and if you're multiplying one of each, a positive and negative, or negative and a positive, you get a negative answer, and that's the same for division as well. Place value, know your place value. Know how to find error interval, so if a number perhaps has been rounded to the nearest 10, know how to write that error interval. Money, so if you've got any money questions, go to Corbettmaths and look at those money videos. But also, whenever you're dealing with money, make sure that if, for instance, your answer is in pounds and you've got some pence involved, make sure it's got 2 decimal places. Best buys. So whenever you're dealing with best buys, it can be useful to find the cost for one of the items or 1 milliliter and so on and compare them. Or you can find the cost for the same amount. Proportion, know how to deal with proportion, and also use of a calculator, be confident in terms of your calculator and how to use it. And that's it. So in this video, we've done a quick recap of all those number topics on the Corbettmaths Revision Checklist, all those red topics. Remember, if you want a more detailed explanation, you can visit each of these video numbers and they'll give you a more detailed explanation on any of the topics.
And that's it. So in this video, we're focused on doing a recap for the number topics from the GCSE Maths paper. So keep up the hard work. You're doing really well. Tomorrow, we're going to go through the statistics and probability topics. So look out for that one. And yeah, so I hope you found this video useful. Cheers. Bye.